Hello and welcome back to Compiler Programming. Today I thought it's time that we add support for 16-bit operands. And even though in here in the instructions we already have the encoding for them, if you note, what happens is 16, 32 and 64-bit operands all have the same opcode, and the difference in sizes is indicated to the processor via a prefix. In case of 64-bit, that prefix is rex w. Then this is considered like the non-prefixed version, so the standard one. And for 16-bit operands, you have prefix 66 in hex, as far as I understand. So this is what we will try to do today. Let's first verify my assumption about that prefix. So if we do something like move ex 0, that should give us, oops, sorry for the whiteness. So this gives us B8 and 40, so it treats it as 30-bit immediate, and we have this value. Now, if we try to do just AX, which is a 16-bit value, let's see what that will do. And it looks like this is indeed 66 prefix, and then instead of 4 bytes, we have just 2 bytes. So there are a bunch of places, unfortunately, in the compiler where we have these hard-coded byte sizes. So let's just start with the encoding itself and then slowly work our way through the compiler and see where we need to add support. Now, we also probably want to do a test, so let's do it that way, and we would say that it how the best to do this. I guess the best way would be to like have a function that would be add 1, and this function would accept an S16, so we would say that x is S16, and we would get back and S16, and here all it will do, it will say x plus 1. Should parse and correctly deal with 16-bit values. Okay, we have add 1 and 1, and here we say S16, and we say that actually type S16 to S16, which we probably don't have yet because we were not really dealing with that stuff. Yeah, we don't have 16 bits here at all, so let's start having them. So we have S16 to S16, and obviously 16 here and 16 here. Okay, so this is as far as cast goes, and we have like checker, and we say that checker of, I don't know, 8 is 9. Okay, so, and I guess we can try to verify that this is indeed a 16-bit value by trying to force a wraparound. Maybe, yeah. Well, let's start with this stuff, and we'll just look at assembly and verify that everything is fine. Okay, so this is good. We have the checker. Let's see if that builds. Okay, it builds, but if we try to run that, we will see a bunch of problems. So maybe we can also tackle them from that side. Okay, yeah, we don't know what the hell is S16, and I think it is defined it is somewhere over here. Yeah, we have type S64, type S8, and now we would have type S16 as, whoops, wrong button, S16. That means here we actually already have S16, so that's pretty good. But we also need to actually end them to the right place, and I think that happens, yeah, that happens here. So we have S16 and S16. That sounds good. Now that should go a little bit further in the compilation. And it says that we don't know what to do with move sex R16 R8. Okay, let's check if such a thing even exists. Move SX, move SXT, and yes, it does. So this is the code, and we can probably use this one, which is, or this one, which is slightly easier. Okay, this is also something for us to consider, that they say that we should be using Rex, but yeah, let's see. Actually, no, we need this one. So 0fbe/r. Okay, let's add it to our instruction. So we have move sx, and let me see. So I have, okay, so basically BE is the one with this stuff, so I guess it should be just like this. And BF is from 16. Yes, something like that. Not exactly sure what these do, because they seem to be moving from the same size to the same size. But okay, that's not the important part for now. This should fix our current problem. And it does, and now we crash quite spectacularly because the encoding is incorrect. At least that's what I assume, and that's something we can verify by opening our debugger and seeing what is going on. Inf mass solution. Then wait for this to actually start. And we are going here, and we are saying S16. Okay, so this is our S16, and let's see what's gonna happen once we are there, and see where we actually fail. So yeah, we encoded something, but that something is obviously very, very wrong. Now we can try to figure out what is happening. Okay, so stack reservation, that's perfectly fine. We put it in EX, okay, that's okay. And then we are saving EX, loading EX, and the problem happens. So my assumption is it crashes on this instruction. Probably. Let's see. Not really. Oh, okay. I guess what happens is because of the wrong sizes, we end up overwriting part of the return address and we jump in the middle of nowhere and the whole thing explodes. So let's not do that, shall we? We have somewhere detection for so this is detection for the 8-byte size, and we should add another one that says if operand byte size is 2, then we say u8, or we can say bool needs 16-bit prefix. By default this is false. Here we would say yes, we do need 16-bit prefix, and in here we would say if this, then we add the prefix. Honestly, I'm not sure if we can have both in some kind of combination, or that doesn't make sense, but for now this should be what we want. So let's try that again. And so I will go straight to the assembly because I want to see that we at least put that prefix in. And it looks like we indeed put it there, so that seems good. Okay. So we do all of this stuff, and then the question is, does it work or does it not? Okay, it looks like we are actually successful, so let's run the tests and see what is going on. Okay, that was pretty straightforward, but there are still a few places where we need to just mechanically go through and deal with the sizes. One that I definitely know it has to do with immediates. So we right now do not have a 16-bit immediate, but they do exist in the nature, as far as I understand. So yeah, we could totally have 16-bit immediates, so that's something to do. Okay, if we just even add it here, it will already, the compiler will yell at us and say, no, you haven't handled this stuff here, so please do. No problem. We can do that. We say 16, 16, and here it will be 4, 16. So this should print out. What else is happening? Yeah, we don't have immediate 16 in operands. Okay, that's not an issue. We can do that as well. Okay, so that actually fixes the issue there, but let's search for immediate in a few more places. So we have operand is immediate. We need to add it here definitely. Then we have value from signed immediate. Okay, we have a fix me here. So that's something that we can do now, where we say S16, S16, and S16. Okay, let's see if that makes sense. Okay, we don't have value from S16. Okay, more things. This is what I meant, that yeah, we have quite a few places that deal with this stuff, and I'm not sure if there is a better way to do it, but for now that's what we have. So you have to deal with what you can. And that's another one, right? We have 16 here, 16 here, and so like this. 16. Okay. Yeah. Here I forgot to put another 16 over here. So that is good. Let's say immediate. Okay, that's fine. I also want to know about byte size and descriptor byte size. That should actually be fine because we have those byte sizes here, I believe, somewhere. Yeah, so these byte sizes are perfectly fine. Yeah, otherwise we would also have problems with stack stuff. Okay, well, that seems good. I want to quickly look through the... No, I don't want to open Visual Studio. I want to quickly look at this function and see what is happening immediate. So, okay. This is clearing. I guess we should support this as well. Okay, let's run the tests now to see that everything is still fine. It is. Good. Let's continue with this stuff. This is 64-bit stuff. Okay, there is nothing else here actually, which is very, very good news. That means that the rest of the code already uses helpers like operand is immediate and such. Okay, that is good then. And that would be all for today. I think this was much easier than I anticipated, and now we support 16-bit operand, which is nice. So thank you very much for watching, and hopefully see you next time.